Okay, today we're going to talk about exponential growth and decay. Exponential growth is where whatever you're talking about is getting larger, so it's going to curve up like that. And with exponential growth, it's all based on this y equals a times b to the x power that we've been talking about. But when it's talking about growth, we're using this formula right here. Y equals a times 1 plus r to the t power. And here y equals the final amount. A is the initial amount. R is the rate of growth. And if you remember, whenever we use a percentage, we have to change it to a decimal. So let's write as a decimal. And t is going to be the times, the number of times that it's going to happen. Okay, so let's look at an example right here. So let's say y equals 1.5 times 1.40 to the t power. So you'll be given this equation. And what is the initial amount here? The initial amount was A, so the initial amount is going to be 1.5. Now we want to find the rate of increase. So if we look over here, we added it to 1 to get R. So if I take 1 away, R is what's going to be left. So let's take this 1.40. Let's subtract 1. And so we're going to get 0.40, and then let's write that as a percent. So 0.40, move the decimal 2 places, becomes 40%. Okay, now let's look at this problem right here. So a college's tuition has risen 5% each year since 2010. If the tuition in 2010 was $10,850, write an equation for the amount of tuition t years after 2010. Then also, we're going to use that equation to predict the cost of tuition for the college in 2025. Okay. So, we have y equals a times 1 plus r to the t power, which is our growth equation right here, exponential growth. So let's plug in. We know that the initial amount was 10,850. And then 1 plus, our rate is 5%, so 5% as a decimal is 0.05. And then that's going to be to the t power. So that becomes y equals 10,850. 1.05 to the t power. So there's our equation. And so now let's predict it in 2025. If we're going from 2010 to 2025, that's 15 years. So let's let t equal 15. So let's plug it in. So y equals 10850 times 1.05 to the 15th power. Put that in your trusty calculator, and let's estimate that to hundredths. Let's take it to cents, which is money. And so it's going to be 22,556.37. Okay. So now let's talk about compound interest. We had a compound interest formula last year that actually looked very, very much like this, except this was an A and that was a P. And so what we're going to use this year is going to be a little bit different. This was compounded annually, so that's why there wasn't this other part like there is here, which is N. So let's go ahead and fill out what these are. So A is going to equal our current amount. P is going to be the principal, which is our initial amount. R is the rate as a decimal. N, and this is the part that's new, N is going to be the number of times it's compounded each year. The number of times it's compounded each year. And then T is going to be our time in years. Okay, so let's look at example 3. So Maria's parents invest $1,400 at 6% annual interest compounded monthly. How much money will be in the account after 10 years? So first, monthly. How many months are there in a year? So that's going to be 12. So let's write our formula down. Y equals P to 1 plus R divided by N to the N times T, where the amount equals the 1,400 times 1 plus the rate as a decimal is going to be 0.06 over the number of times it's compounded in, which is going to be our 12, times to the power of 12 times the number of years, which is 10. If you plug all that into your calculator, and I would put it in exactly like that, even put that fraction in just like that, that's going to come out to be 2,547.16. And remember, pause this if ever you need to pause or anything like that. Okay, please let me know if you have any questions. Now we're going to flip over to the back of this sheet, and we're going to talk about exponential decay. So if growth is where it goes up to the right, decay is going to be where it goes down to the right. So it's going to go down to the right if it's decay. Okay, so we're still starting out with y equals, there should be an a in front of that. A to the bx power, a times b to the x power. But this time, with decay, instead of adding the rate, we are subtracting the rate. So that's a big difference right there. We're subtracting the rate this time. So if we look at this, let's do example. We have y equals 0.15 times 0.045 to the t power. So our initial amount here is 0.15. So we're not starting out with very much. Now the percent of decrease. Now, when we looked at the percent of increase, flip it over to this other side, we subtracted 1 from it because it was what's left. Now this is going to be a little bit different here. Here we're going to subtract it from 1. So I'm going to put subtract. I'm going to put b, because b is the number there in the parentheses. Subtract b from 1. So we're going to have our 1.00. We're going to subtract 0.045. I need to go ahead and add a 0 there to make them line up. We're going to have to borrow, so that becomes a 0. That becomes a 10, which is going to be a 9. Make that a 10, which is going to be a 9. Make that a 10. So this is going to be 5. 9 point. So if I convert this to a percent, we're going to get 95.5%. Remember, so if it's decay, you're subtracting it from 1. If it's growth, you're subtracting 1 from it. Okay, so let's look at example 5. This will be the last thing we'll do here. So a fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. Write an equation to represent the loss of air. So let's go back to our y equals a parentheses 1 minus r to the t power. So y equals our initial amount is 4,500. 1 minus our rate, 6.6% as a decimal. Move it 2 places. We get 0.066. And then to the t power. And then if I go ahead and subtract that, I get y equals 4,500. I subtract that, I'm going to get 0.934 to the t power, which is our answer for A. There we go. So now let's estimate the amount of air after 7 days. So we have y equals 4,500, 1.934. T, the number of time periods, is 7, so it's going to be to the 7th power. And put that in your trusty calculator, and we get approximately 2790.23 cubic inches of air. Please let me know if you have any questions, and I'll see you soon.